May 11th, 2016. I drew a little graph here. It's kind of dumb, but you guys can understand. This is the count of the exoplanets found by the Kepler. Now, what you'll notice is that there's this big hump in the center. Now, that hump right there, and this is the increasing size, the hump right there is very important. If you'll take a gander at that, you'll see the Kepler hump, if you will, and how they ignore the larger bodies. But basically, that's what's going to end up happening. And I'm predicting they're going to do this because their theories are bunk. What's actually happening here is that you have they're only counting the ones that fit what they believe is going on, meaning they have exoplanets distinctly different from star. So you have a bunch of stars and you have exoplanets, but what they're not telling the public is that there's this huge gap of what's called false positives. Now, in stellar metamorphosis, these false positives are intermediate age stars. The young ones that shine are obviously the young ones, and these are the older ones, which are called exoplanets. Now, what they're doing is they're ignoring all the false positives, all those light curves where the star can be seen to have a light curve, when it dims a little bit and it's, oh, well, that's a star orbiting another star. It's a binary system or something like that. But little do they realize that they're not related, that they're stars in different stages to their evolution. And the exoplanets that the Kepler scientists are finding are the really, really, really old stars, the stars that are billions of years old, similar to the Earth. But they're not going to look at it in that kind of light. So what they're going to do is they're going to skew the data more and more and more as the days progress. They're going to find all these stars, and the exoplanets are going to be up here, and then there's going to be this huge gap where the brown dwarfs and intermediate age stars are. They're not going to talk about these very much, not realizing that these were these at one point, and these will evolve into these. So they're all the same thing, only in different stages of evolution. And I thought this was really funny. Wanted to go ahead and read it out to you. Now, the Kepler Space Telescope has its lens. Actually, I'm not going to read that one. That's a different article. The Kepler Space Telescope has its lens trained on 150,000 stars and their light curves. And they say, well, we have to find the planets in front of them. Little do they know, the star is the young hot exoplanet. So essentially, the Kepler, they started out finding 150,000 planets right off the bat, right when it looked up at those stars, because they're the same thing. Now, they're going to send up a new telescope called TESS, T-E-S-S, I believe, but that one's going to be trained on 200,000 stars, which are young exoplanets. So right off the bat, they have discovered 150,000 plus however many older stars they found here, so it's 151,000, 152,000, something like that. And now they're going to send up the TESS, which is going to look in a different place, and they're going to look at the light curves of 200,000 stars, which are young exoplanets. So their actual exoplanet count is around 352,000 exoplanets, because that's what a star is. It's a young hot exoplanet. I don't know if they're going to correct themselves, but it's going to happen within the next maybe decade or so, when they're going to realize that the ideas that they've been holding on to, which were rooted in the 20th century, were incorrect. But it's not up to me. I just want to make sure that people are aware of what's going on. Yeah, but good luck on finding the older stars. They're really dim. They're really small, and unfortunately, they're called planets. I don't know when they're gonna fix that. But anyways, all right. Later, y'all.